So again, just waiting a couple minutes to give people time to get into the session. We're about 2 minutes past the hour, so we can go ahead and start to get started. So again, welcome to this ISI session on nowcasting. Nowcasting has taken on some additional visibility in the wake of the COVID-19 pandemic and the need for real-time indicators on both the economy and the epidemiological situation. So it's pretty exciting to bring these presenters and presentations together today. So we have some interesting presentations on both various new methodologies in nowcasting, as well as some really interesting applications. So with that, I'm pretty excited to get into it. So our first presenter today will be Giulia Martini from the World Food Programme, speaking about the hunger map. So with that, let's, oh, and one last thing. If you could please put your questions in the chat. We're going to have about 10 to 15 minutes per presenter, and then 5 to 10 minutes for a Q&A. So please put your questions in the chat, and then I will ask them to the presenters at the end of their presentation. So with that, I'll give it over to Giulia.
Yes, hi everyone. I'm Giulia Martini. I'm a data scientist at the Hunger Monitoring Unit in World Food Programme, and today I'm going to talk about the hunger map and in particular about our progress in tracking and predicting hunger in near real time. And I will talk more in detail about our nowcasting model. So at the end of the presentation, you will know more about the method we used, the current accuracy of the model, and the challenges we face. But yeah, let's start with what is the objective of the hunger map? The objective is to help assess, monitor, and predict the magnitude and severity of hunger in over 90 countries in close to real time. How do we do so? We do that combining near real-time monitoring, hunger predictions, and also a series of additional data related to conflict, hazards, population, for example. And all these data are consolidated in one central system and then are converted into user-friendly visualization that is displayed on the hunger map. In detail, the near real-time monitoring works in the following way. So there are continuous data collected remotely through live calls. The data collected are the same indicators as the ones in the integrated food security phase classification analysis. And the data that we collect are representative data on the food security situation on a country level, or actually at a first administrative level when it's possible to do so. And this data is analyzed automatically, and the results are made available in near real time. So every day on the hunger map, you can see new data displayed. We started in 2018 with the near real time monitoring with 3 countries in Nigeria, Yemen, and Syria. Then it was expanded to other 8 countries, so for a total of 11 in 2019. And then we reached 35 countries in 2020, and this is huge. Scale up was also due to the needs that arose because of COVID-19. At the moment, 38 countries are covered by the near real-time monitoring, but there are still many countries and actually many first-level administrative areas where the near real-time food security data is not available. So we still would like to estimate the number of people with insufficient food consumption and the number of people with crisis level or above coping strategies. And to do so, we use a predictive model that is fit using historical data and secondary data. These data are related to the 3 main drivers of food insecurity, or what the experts consider the 3 main drivers of food insecurity, that are conflicts, extreme weather events, and economic shocks. Our model was fit using indeed secondary data and historical data spanning 78 countries and across 15 years, so from 2006 and 2021. Our model predicts 2 indicators. The first is the prevalence of people with insufficient food consumption, and for who is familiar with this indicator, it means food consumption score poor or borderline, and the prevalence of people using crisis or above crisis food-based coping. The second indicator is that we predict is the prevalence of people using crisis or above crisis food-based coping. So reduced coping strategy index of 19 or above 19. The prevalence in general is a number between 0 and 1. So what we are facing is actually a regression problem. And to solve that, we use a machine learning algorithm that is called gradient boosting. In particular, we use the XGBoost implementation. Gradient boosting is a very flexible algorithm and is very flexible method. This is the main advantage, and is an ensemble method where multiple decision trees are fit in a series, and each tree is fit on the residuals of the previous one. So as I said, we have two indicators, but in general we are interested in making prediction at the first level administrative areas where a loss assessment is available, but also where we don't have that. So for this reason, to achieve the best result possible, we have actually 4 models, 2 for each indicator that we want to predict. In one, we use the prevalence. In one we use also the previous assessment as independent variable, and in other one we don't use it also because we don't have it. So for the administrative areas where we have a previous assessment, of course we use the model where we also include that one, and for where we don't have it, we use the one where this is not included. For each model, a feature selection process was performed to get a set to get the optimal set of independent variables. And so this was performed independently. So we have 4 sets of independent variables, 1 for each model. And in the table, you can see the list of variables that we use for the model that predict the prevalence of people with insufficient food consumption using the last food consumption score assessment available. So you can see that there are all the main drivers, food security, for example, economic indicators as the food inflation or headline inflation, something related to conflict. Indeed, we have the decrease in battle-related fatalities, and also something related to the weather. Indeed, we have the average rainfall or the average 1-month rainfall anomaly. What we did to ensure the reliability of the model was to train 100 models on subsamples with the replacement. So we actually performed a bootstrap, and we obtained the results for each model that are shown in the table. You can see, looking at the first and third column, that better results were achieved when the previous assessment was included. Indeed, we have a 0.75 R² for the model that predicts the prevalence of people with insufficient consumption, and 0.78 for the model predicting the prevalence of people using crisis or above crisis food-based coping. For the other 2 models, the R² is lower, especially for the one predicting the food consumption score, but still we consider these results satisfactory. How the hunger map looks like. So you can of course Google it by yourself, but I also just wanted to show to you an example. This is a screenshot from a couple of months ago. And you can see, so this is Yemen. So this, as I mentioned, is one of the countries where first started the continuous monitoring. So if you go to hungermap.wfp.org, you will see a world map. You can click on a variety of country, and this is what would happen if you click on Yemen. On the left, you have a series of data. The one collected through the near real-time monitoring are the food security trends on the bottom left, and all the secondary data that I was talking before are available on the bottom ribbon. So for example, if you click on the conflict tab, that's what would appear. Something very similar would appear also for a country where the near real-time monitoring is not in place, but where we have predictions. So for example, for Guinea-Bissau, we don't have the continuous monitoring, but you can see that the food security trends is not just a line as before, but we have a trend like with these flat lines, because it's how our model usually makes prediction, and with a 95 confidence interval. On the right, actually, we also have this other secondary data related to macroeconomics indicator, headline, and food inflation. Of course, in the entire system, we face multiple challenges in setting it up and in maintaining. I just listed a few of them, the more important. So there is little and no standardized data in computer-friendly format. So multiple times for historical data, we need to check on reports and add manually the data to our database. And also it's difficult to find globally available and regularly updated open data with the spatial and temporal resolution that we need for all the desired predictors. And of course, the maintenance of the entire structure that every night runs on virtual machines and produces and uploads results and produces the predictions is also hard sometimes to detect malfunctions. So that's why we are trying to implement a system of alerts and reports that every night would be sent to some of us in the team to check that everything is smooth. For what concerns the model, the main challenge is to try to explain our prediction, because for who is familiar with this model, type of model, knows that it works a bit as a black box, so there is not a clear connection between the input variable and the output variable. So this is difficult usually for people maybe to understand and also to trust the predictions. So we are working on the use of shop values to try to demystify indeed our predictions. Yeah, I just wanted to add that we just published for a review. We just sent for review a paper related to the model. So if someone is interested, of course, can check the preprint. I put link in the slides, as you might have seen. And yes, of course, I'm available for questions now or a different moment. Thanks for the opportunity.
Thanks a lot, Julia. Very interesting. So I'm looking at the chat right now, and I don't see any questions right now. I had a couple myself, and I don't know if any of the other presenters do. But one thing that you mentioned earlier in the presentation was this process of scaling to different countries and to different geographies.
Yeah.
So I just had a question on that process and how difficult it is or how easy it is. I know you were talking about telephone survey data. So is this a framework that you guys have that's very easy to expand to these other countries, or does each one require a team on the ground, a lot of involvement, or is it a simple process?
Well, it's always, okay, so first of all, I'm not the main person involved in this, but what I can say is that we usually work with the country offices that in different countries to see if there is a need. And usually then we have external partners for the surveys that we, that they perform the survey. We don't do it the survey primarily. So, but we train the operators and we are in contact with the operators that perform the surveys. And that is quite challenging usually to find operators and so on.
Thanks. So we do have a question now in the chat asking which were the main indicators that helped predicting the hunger. So what are the main input variables for you guys? I guess.
Yeah, so I will go to the slide where there are the, so of course for each model we check the kind of the importance of the features, but for example, definitely the gross domestic product per capita is important. When we use it, the last available assessment was of course the most important one. Conflict didn't have such a big relevance, what actually we would have expected to find out, but actually the input variables with related to conflict were one of the least relevant. The prevalence of undernourishment was also one of the most influential. So these were the main influential ones. Also, also the exchange rate, like something related to the currency exchange that we defined as the variation of the currency exchange over 3 months is one of the most important.
Interesting. Thank you. So I had another question unless someone else wants to jump in. So it's always really great to see these real world applications of theory and of nowcasting, but I was just curious how people are acting on the information in the hunger map. Is this more just kind of an informational tool, or are there people making solid, concrete decisions off of the information and providing, directing their food aid based on the output of the map, or is it more of an informational tool at this point?
So from country offices, there is definitely a lot of interest. Sometimes what I was saying is this is a bit this challenge that the predictions are not really trusted because there is not a formula, right? As I don't know, if you have a force equal, I don't know, whatever, you have a formula, it's easier to understand what is the influence of one variable to the output. But in this case, it's a bit of a black box. So to have indeed more, let's say, relevance, because so far it was mainly used for advocacy or just a bit as an alert, like, hey, something is happening, let's have a check. Yeah, that's why we are working on trying to demystify the prediction, really to have more impact, say, possibly on decisions.
Great, thanks. So we have a question from Fernando. You can go ahead and ask.
Yes,
sure.
Thank you. Julia, This is very, very interesting. But I had a question. When you put the map for Yemen or for Guinea-Bissau, you so I see there is information by region or I don't know, municipality
Yes,
or
yeah, this is
some
a first
sub-regional level.
Yeah,
Yeah,
yes,
but then
first
when I see
administrative level.
okay, great.
Yes.
But then when I see the variables, most of them look like they're at the macro level. They're like
Yeah, so we have a combination of variables for first administrative level, and some of them are national. So of course, for example, if we have the prediction for Guinea-Bissau, for all the, I don't know how many are 6 province first administrative level areas, some of the input variables will be the same and some of them will be different. So for example, the one related to rainfall, for example, will be at the first administrative level, other one will be national.
okay, thank you.
Sorry, does this answer your question?
Yes, thank you.
Yeah. Yeah, and this is indeed also one of the challenges we were mentioning, that is not easy to find data updated constantly and at the resolution that we would like to have. So of course, we might not grasp some differences between first administrative from, say, regions in one country, because we don't have enough like data so accurate. Yeah.
Great, so we have a couple more minutes. So I had one last question, if no one else has something. So I see, for example, in this slide you have up right now, you have COVID caseloads there. Is COVID information incorporated just as a like a companion information, like, or do you use COVID as any kind of predictor or input to your models, or is it really just
no, COVID was not integrated in the model.
Mm-hmm.
So it's just as a secondary data displayed on the hunger map. Yeah, just as a secondary data, is not integrated. It would have been interesting to integrate it, but the challenge is that you didn't have historical data, where like you would have been all the historical data that we used to train the model where COVID was not there, and you would have been just a bit of sample from maybe 2020 where you had it. So yeah, we decided not to include it.
That makes sense, but maybe in the future an input to the model. So if there are no other questions, we're doing well on time. Thanks a lot, Julia. That was really great.
Thanks to you.
So we'll move on now to my own presentation. Let me start sharing my screen. Okay. Great. So thank you, Julia, again. So I'm Daniel Hopp. I'm working at UNCTAD, also the organizers of this session on nowcasting. So I'm going to be talking today about the use of long short-term memory neural networks in the context of economic nowcasting. So the agenda. So first, I'm going to give a little bit of background information on economic nowcasting in general. So I'm sure many people in this session have some kind of idea what nowcasting is, just to be sure, a little bit of context. Then I'm going to talk about the types of issues that nowcasting type of data issues it frequently faces. Then I will speak briefly on artificial neural networks in general, and then more specifically on the long short-term memory network and their relevance to the nowcasting problem in the economic sphere. And then finally, I will talk about the empirical analysis that we performed at UNCTAD to validate its performance versus the dynamic factor model, which is what we currently use for our nowcast at UNCTAD, and which is a very common and popular methodology in the realm of economic nowcasting. So first, a little bit of background on the field. So the term nowcasting is a portmanteau of now and forecast, and was originally used in the meteorology sphere to refer to the prediction of the weather in the very near future based on its current state. So this terminology was extrapolated to economics, where it refers to the estimation of either the real or the near real-time value of a target variable or a target series using more timely available indicators. So by way of example, GDP is a good one. So GDP is a number that is generally published with a long lag or a long delay. And we won't actually have the final figure for GDP for a period or a quarter until many months after that quarter has finished. So that makes it a really good candidate for nowcasting. And it's one of the more commonly nowcasted macroeconomic variables. So though GDP itself is published with a significant lag, there are other indicators of GDP and of the economy in general, which are published much more quickly than that figure. So that's information like consumer surveys, purchasing manager indices, data on marine traffic and trade. So we can use all of these more timely available indicators to somehow estimate the value of GDP well before the actual value is published. And so that's called a nowcast because we may be nowcasting, let's say, the second quarter of 2020, even after the second quarter has passed, because the data takes so long to be published that it's still a useful exercise to try to predict or say what Q2 GDP was, even after the period has passed. So in this domain, there's a couple of different data characteristics that arise when you're trying to solve this type of problem. So the first is the mixed frequency of data that you're working with. So for instance, we may be trying to nowcast a quarterly variable using monthly variables, or we may be trying to nowcast an annual variable using a mixture of monthly and quarterly variables. So any methodology that you employ for nowcasting has to deal with this type of mixed frequency in the data somehow. A second commonly arising issue is that the explanatory variables in your model will generally be published with very different publication schedules. So it's not like on this day, all the data for this month is published and you now have complete data for that month. It's that, this particular series will be published just 1 month afterwards, and the other ones might take 3 months. So you have a phenomenon called ragged edges commonly in the space. So that's where you will have different latest data available depending on the economic series and the publication schedule for that series. So that's another characteristic that any methodology has to somehow be robust to. Then another common issue is the cursive dimensionality. So this is where we may have relatively many more variables in our model than we do observations. So if we're nowcasting a quarterly or an annual variable, we may not have that much history or that many observations of the target series, but we may have many more potential explanatory variables. So this is a common, you end up with problems of collinearity, etc. So again, the methodology for nowcasting should be somehow robust to this characteristic. There are, of course, other data issues that are relevant to nowcasting, but these are just 3 of the kind of most prominent or most important. And again, any methodology for nowcasting should somehow have provisions for dealing with these characteristics. So that brings us to the artificial neural network and how this can be used in this context. So first, I'll give a little bit of background on the artificial neural networks in general and kind of the concept behind them. By this point, many of you may have a little bit of background information on them, but if not, this is a very quick overview. So in a generalized sense, neural networks are composed of layers of nodes, or neurons, that's where the terminology comes from, which at their core, they transform input data via weights to obtain output. So if we take this diagram here, I'm not sure if you can see my cursor, but if we take the first row of this blue diagram, the leftmost layer represents the initial data that we're working with, our input data. So if we were nowcasting GDP, this would be our economic survey data, our marine traffic data, etc. The data would then flow through the network, be multiplied by the weights, so this W1, W2, etc., and then combined on this hidden layer, so the second layer. And these weights are initially randomized. And then once you move to the next layer in the network, the outputs are run through a nonlinear activation function. And this is an important characteristic of neural networks, which enables them to find nonlinear relationships in data. I think it's the source of a lot of their power. And then you can continue this process with as many layers as training or as need specifies. And then eventually you'll end up with your output or your prediction. You then run this prediction through a cost function. So this can be something like mean absolute error, root mean square error for a regression problem, like we're dealing with most of the time in economic nowcasting. And then you can use this cost function to perform gradient descent and update the weights of the network in the direction of minimizing this cost function. So you're tuning the network to minimize your error. And then once those weights have been updated by following the gradient by some small amount called the learning rate, you run the data through again with a new weight, you obtain a new output, and you run through the cost function again, and you repeat this process many, many times. So, and then once you've minimized the error, the network is considered trained or fixed, and then you can begin using that network for inference. So running new data through the trained network, which at its core is these weights. And then you can have inference and predictions on new data. So this is the traditional feed-forward artificial neural network architecture. And these are super powerful for a lot of different applications, but they do not have a time component. So it's usually used for independent observations. So things like photos, etc. So in the nowcasting context, of course, the time element is very important. Most of the data is time series, and we're trying to predict the latest iteration in a time series. So we need some way to incorporate time into the architecture. So the recurrent neural network is an adaptation of the feed-forward network, which introduces a temporal aspect to the networks. However, they come with their own set of issues that make them a little bit not so well suited to the nowcasting context. The biggest one is they suffer from something called vanishing gradients or exploding gradients. Basically, they have a very short memory, and that limits their usefulness in the nowcasting context. So that is where the long short-term memory network comes into play. And this builds off the recurrent neural network, however, introduces something called a forget gate, which is a very important component which allows the gradients that I talked about earlier to flow through the network unchanged, and thus makes the network have a much longer memory, being able to deal with much longer time series. And that is ultimately what makes them so useful for use in a nowcasting context. So LSTMs traditionally have been used or are very popular in natural language processing, speech recognition, other types of things where there's a temporal component. However, they have not been used that much in the economic context. There are a couple studies on it, but it's largely a new domain for the methodology. So then how do the LSTMs then, how do they stack up in this nowcasting context? How are they able to handle these issues that I mentioned earlier? So the networks can deal with mixed frequency data by being able to learn the complex nonlinear relationships in the data via that nonlinear activation function I mentioned earlier, which means that you can put in mixed frequency data with something like the mean for missing values, and the network can learn to kind of disregard those intermediate values and focus on the quarterly values, say, and skip the in-between months. The ragged edges that I mentioned earlier can in turn be addressed with various methods. So in the empirical analysis that I'll talk about a bit afterwards, we use the mean and an ARMA model. So basically you're estimating what the next value is and using that as an input to the model. So this is not particular to the LSTM architecture. It can be treated as sort of a hyperparameter, and various methods can be tested with it. But again, in our empirical analysis, the mean and ARMA were both well performing in that role. And then finally, the networks can handle huge numbers of input variables. So in this plot here, I have how the performance time or the model estimation time scales as the number of input features increases. So here, the red line on the bottom, we have the LSTM neural network, and we see that as we add more and more features to our model, the model actually is hardly scaling at all, the model estimation time. Whereas I have two different implementations of the dynamic factor model, and they both are scaling exponentially. So as we get up to more and more input features, their performance gets longer and longer to estimate a new model. This depends on the implementation of the dynamic factor model you're using. There are some that can handle many more input variables, but right now what we're using at UNCTAD, these are the limitations that we're up against. So that's good in theory, but then how do we validate this in practice? So to validate it, we carried out an analysis comparing the LSTM's performance in nowcasting to the dynamic factor models that we currently use. So we had three different target variables, which were global merchandise exports expressed in values, merchandise exports expressed in volumes, and then finally global services exports. So to test the two different methodologies' performance in this exercise, we had a large pool of potential explanatory variables, which we then trained both DFM and LSTM models on over a training period from 2005 to 2016 and a test or evaluation set from 2016 to 2019. Then for robustness, we took 100 random samples of between 5 and 20 of this pool of variables and trained LSTM and DFM models on those identical variable sets, and then assessed that performance on the test set, so this 2016 to 2019 period. So the analysis was performed on 100 different subsamples of independent variables for robustness. So if we were to only test this on one particular set of independent variables, either methodology could be superior in that context just based on random chance. So by sampling 100 different random samples of independent variables, we can have a much more robust idea of, on the aggregate, how are the methodologies performing. This is an interesting question of variable selection, which actually Fernando will touch on in the next presentation. So keep it in mind and you'll learn a bit more in the next presentation. So these are the results of the analysis. So in the columns, we have our two different performance metrics. So the mean absolute error on the left and then root mean square on the right. And then in the rows, we have different data vintages. So ranging from 2 months before the target period, when not very much data is available, to 2 months after the target period, when the majority of data for that period has been released. So the reason that we test on different data vintages is that over the course of a nowcast, the methodology should be able to have good predictions early in the cycle when there's not much information available, as well as later on. So a methodology that performs very well 2 months after, when your data is almost complete, may be very useful then, but 2 months before, when not much data is available, if it performs very terribly, that's not necessarily a very effective nowcasting methodology in the holistic sense. So then what these distributions are showing is the three different target variables. So the red is the export values, the green is volumes, and then the blue is services. So basically, these are the distribution of the 100 random subsamples of independent variables, and then plotted the LSTM error as a proportion of the dynamic factor model's error. So the black can be kind of taken as the baseline, our current outputs. So if we have distributions centered around the black line, that's indicating that the two methodologies have similar predictive performance. So if we look at global services in root mean square error, this blue distribution is centered around the black line, which means that more or less we're having pretty similar predictive performance. However, we see that most of the distributions, in fact, all of them except this blue one, are centered to the left of the blue line, which indicates that on average, the LSTM is having significantly less error than the DFM. So those are, of course, promising empirical results, but even leaving aside that performance, we have other characteristics of the models that we can compare. So on the empirical predictive performance front, there should, of course, be more testing and validation on different time periods, on different target variables, just to ensure the robustness of those results. Maybe there's something special about merchandise exports and services where the LSTM is better suited. So that should be further validated. But there are some characteristics which are independent predictive performance that we can still compare and contrast between the two methodologies. So some pros that we saw in a previous slide was that the LSTM can handle many more input variables than the dynamic factor model implementation that we are currently using at UNCTAD. And then on top of that, that the methodology does not run into any estimation or calculation problems, which the DFM sometimes can do due to uninvertible matrices, etc. And then on top of that, it's simpler to add new frequencies, data frequencies to the long short-term memory network. Can handle theoretically daily data mixed with yearly data, mixed with even theoretically hourly data. Of course, that needs to be tested, but in theory, there's no limitation to that, where the DFM requires a little bit more tuning or tweaking to accept other frequencies. And then so on the cons front, we have the stochastic nature of both neural networks in general, but also, of course, of the LSTM network. So this comes from what I mentioned in my neural network slide, where the initialization of the weights is initially random. And that's just to provide a starting point for the network. So this little stochasticness means that two models trained on the exact same data will give two different predictions. So this can be mitigated a bit by training many networks and taking their average or their median and other more complex ensembling methodologies, but it is a factor, the stochastic nature of neural networks. And then next is the lack of interpretability in parameters and lack of inference as to what is driving the decisions or the changes in the network's outputs. This again is a problem common to all neural networks, but there's a rich field on how to get interpretability out of them. But in the LSTM nowcasting context, that's an area for further research to try to get a measure of interpretability from these models. And then there's a couple of things where whether it's a pro or con kind of depends. So one is the estimation time of the two methods. This is highly dependent on the hyperparameters of the LSTM and on various EM convergence of the dynamic factor model. So you have a little bit of variability in which one is actually faster in estimating a model. But generally speaking, in the empirical analysis that I did, the training one single LSTM model is almost always faster than training one single dynamic factor model. That advantage kind of goes away a bit when you have to train multiple models to get a little bit less of that stochastic element to the LSTM's outputs, but nevertheless, one single LSTM generally will be trained faster than one single dynamic factor model. And then finally, the LSTM takes many more hyperparameters than a dynamic factor model. So this is a pro in the sense that the performance of the model can be improved and tweaked, but it's a con in the sense that that takes a lot more effort to properly leverage on the side of the analyst or the statistician who is doing the analysis. So in conclusion, the research on the LSTM has shown it to be a promising methodology in the nowcasting space with desirable characteristics which might help expand applications for nowcasting, expand its application from just the very classical macroeconomic variables to some of these newer SDG indicators. But of course, more research needs to be performed. And on this final slide, which I assume will be made available via the ISI portal, I put some additional resources, including links to the Python and R libraries that was created alongside this research so that anybody could use these models for their nowcasting applications, as well as links to the UNCTAD research paper, which is detailing this methodology in much more detail in this presentation. And then finally, the UNCTAD research paper on the dynamic factor models that we currently use and which was contrasted with the performance of the LSTM. So that's it for me. Thanks a lot. Let's see if there were any questions in the, I don't know if I can see the chat while I'm sharing. Let me stop sharing and check. Okay, I don't see anything there. But if any participants have any questions or anyone else? Okay, so
Daniel, sorry, may
yes, please.
I don't know a lot about neural networks, but I was thinking, you mentioned that different models learn a different way. In econometrics, you define criteria to see what is better. Do you have something similar to compare models and how they perform?
So do you mean something beyond the so I had been using the empirical performance on these test series, and just root mean square and mean absolute error on the in comparison to other methodologies. I am working now on some more research using the development of the forecasts over time as another metric for their usefulness in the nowcasting context. But for now, it's mostly around empirical performance on these series. I don't know if that answers your question, or if
Yes.
there's other metrics. Great. Then we are, if there's nothing else, then we are right on time for heading to Fernando's presentation. So Fernando, I'll give the floor to you.
Yes, thank you, Daniel, and hello, everybody. My name is Fernando Cantu. I'm the Chief Statistician of UNIDO, the UN Organization for Industrial Development. And today I would like to give you just a brief summary of our experience with nowcasting and some of the challenges we have faced. In particular, one of them, which is the issue of model selection. So I will start sharing my screen. Dan, can you please let me know if you see it?
Yes, it's working.
Okay, thank you. Okay, so Dan already provided some background on nowcasting, so I will, which is very good. And I just as an additional piece of the context, I want to just mention that there has been a growing interest in all these sort of predictive analytics in the context of development, particularly since the start of the SDGs. As you know, there's many indicators associated with the SDGs, more than 200. And when people started to look at them, they saw that in many cases, the data was just not there, or it was there, but it was old or incomplete. And this really presents an obstacle, because we have a set of targets that we want to accomplish by 2030, but we have not a lot of supporting evidence of where we were at baseline and where we're heading to, and if we are moving in the right direction or not. So there has been a lot of initiatives and I think this has been very good for statistics, particularly in the context of development. A lot of efforts to bridge these gaps by improving data production at the country level, but also by using different sorts of analytics to fill the gaps as much as possible, when possible. So here I have some quotes from this Global Partnership for Sustainable Development, which are the main partners, I guess, or one of the main partners for Data for Now initiative. But this is also mentioned, for example, in the Secretary General's data strategy that was released, I see 2021, it's a mistake, it should be 2020, last year. And also in the system-wide roadmap for innovating UN data and statistics that very explicitly mentions the issue of nowcasting. So it's great, there's a lot of interest on this. For us, it opens up a lot of very interesting areas of work. But it's also brings a lot of challenges, and this because SDG indicators, they are all over the place. There's many different areas, very different levels of aggregation, and some of them we can get a lot of information of what's going on, some of them less. So it's let's say, it brings up a lot of challenges on how to do any sort of predictive analytics on these indicators. Also, another problem is the custodian agencies for the SDG indicators are not expected to only provide kind of a global estimate or a regional estimate, but more and more people are requesting country level data, and even more disaggregation in, I don't know, going by industry if it's an economic set, or by population group if it's a kind of a social development indicator. And the custodian agencies have to respond to all these and to provide the required information to a wide audience made of statisticians, but also policymakers and other users, with, of course, very limited resources. So there is a need for nowcasting methodologies that are transparent, easy to communicate, easy to explain and to describe, that perform well, obviously, but also that are simple and can be scalable to these kind of multiple estimates that are required in this SDG era. So we are UNIDO, we are custodians for 6 SDG indicators, all of them in SDG 9 related to industry. So we're not one of the most, we're one of the traditional ones. It's just manufacturing. That's one of the variables that are most followed in economics. So there's a lot of history of forecasting or monitoring these variables. And you would say, well, maybe there's not a need for nowcasting in this context, because there's a lot of data in industrial production. Many countries have industrial production indices that can be used. But the problem is that, as Dan was mentioning before, that not all countries have these indices of industrial production. Some of them have monthly, some of them have quarterly only. Some of them are released very late. And also, and very importantly, the SDG 9 indicators are based on manufacturing value added, which is a concept from national accounts, and doesn't necessarily match always the concept of manufacturing output or production. So of course, they're very related, but they're not the same. So at UNIDO, we took this challenge and we decided to implement a dynamic factor model using an EM implementation. As you can see, this is the one used by the Fed in New York, by the European Central Bank, or was used. So it's a very common methodology. And for now, this is a work in progress. We're starting with the kind of regional and global nowcast. So we're trying to estimate global manufacturing value added and by main regions in the world. But later on, we want and we have to expand to country level nowcast, and even in some cases industry level, at the ISI 2-digit level at least. See here, I will present a couple of results using just as an illustration the global manufacturing value added. So the first thing when we started this exercise, we started to think, okay, what variables we can put into the nowcast can give us information about what's happening on global manufacturing value added. And we came up with obviously a huge list of hundreds and hundreds of indicators. So the question was, what variables should we keep in the model? And I feel that this has been a relatively neglected area in the nowcasting literature. Many of the papers on nowcasting GDP or other macro aggregates, they just start with a list of indicators and then they apply the methodologies. And I guess this makes sense in those situations because but there's a lot of work being done in this area. So I will not say there's a consensus, but at least there's a lot of experience and a lot of work on which variables proxy or coincide with the trends in GDP and can be good candidates for nowcasting. But in other contexts, it's not as obvious. Industry or manufacturing value added is also fairly straightforward, but I'm also want to expand to kind of a general situation where you're asked to nowcast random sustainable development indicator, and you have a lot of candidate variables, and you have to decide which ones should be included and which ones not. And also, of course, when we're dealing with regional or global variables, then the available indicators multiply, because we also have the country level information there that we can use separately, and that can also provide information. And as has been mentioned before, this creates a cursive dimensionality where we have becomes more and more demanding to estimate these. Sometimes impossible because we have many more variables than observations. And of course, there's a huge risk of overfitting, plus it's very taxing to maintain and then to communicate the results from the point of view of an international organization. Okay, so this is not a trivial problem as well. So here what I did is back in maybe May, I was doing testing the model for and see how it was indicating for the first quarter of 2021. And this is a quarterly growth rate. And I created 100 models taking 10 variables at random from a pool of about 300, 320 potential candidates. So I took 10 variables at random, and then I saw what was the nowcast for the first quarter of 2021. And you see here the results. You see it's all over the place. Most of them are concentrated between 1% and 2%. Some of them go up to 3%, which is a huge rate for not huge, but it's a big rate for a quarterly growth rate. Some of them are even negative. So it really makes a difference which model you take. It will produce different results. Maybe you are thinking, oh, but 10 variables is a very simple model. If you put more, maybe it will improve the performance, and it does. Here, the blue histogram is 20 models with 20 random variables. So it converges more to around 1.5, but still there's a wide variance in the estimators. Also, with hundreds of variables, it's impossible to test all of them. And even if you use standard kind of model selection procedures, it's also not possible. It's just not possible to do. Backward elimination, you have to start with the entire model, and that cannot be estimated in many cases. Forward selection will force you to test thousands and thousands of models. That is also not feasible in general circumstances. And contrary to, or in general, there's no theoretical model to guide you. So we at UNIDO, we settled, at least for now, in a kind of an ad hoc alternative. We adapted these two papers on model selection, Kai Alia, Heitz Alia. And here the idea is to just not take all the candidate variables or candidate indicators in the same way, but impose some sort of structure in an exogenous way, like from based on subject matter knowledge or previous experience or what other estimates say. And this, the idea is that of all the potential candidates, we can divide them into groups that make sense from a kind of subject matter point of view. And this group structure will really help us into move forward with the model selection. I will go into a bit more detail on the algorithm later, but first I want to talk about the selection criteria. So here we don't really use metrics based on significance, because as we know, there's so many variables that we can just add more variables and increase the significance with a huge risk, obviously, of overfitting. But this cannot really be used. Also, the kind of change of estimate metrics are of limited interest here, because we're not really interested in the coefficients of the dynamic factor model. Sorry. We can use them, of course, to test the stability of the model, but this is not the main objective of the estimate. So we also do a kind of a out-of-sample validation, very simple, where very classical. We divide the sample into two, a training and a validation set. We estimate the parameters of the model in the training set, and then we evaluate the performance on the validation test by using a very simple metric, the absolute prediction error. So what is the algorithm? So we start by, so imagine we have hundreds of variables, potential variables. We start with an initial model with a very limited number of key variables. For example, in the what Julia presented at the beginning, she said that there are some known drivers of food insecurity like conflict, drought, etc. So we can use some of them as a kind of an initial set, but this is optional. We can also start with empty sets. So we divide all the variables into G groups, and then we do separate forward selection for each group using just prediction error as a selection criteria. Like that, we will have some models by group. Then we put all the variables together into some sort of supergroup, supermodel that has all the variables. But of course, these variables have never interacted with one another. So then we estimate the model and we do a backward elimination to see which ones we can start removing. And the variables that are dropped go back to their original group. And then we iterate this process until convergence. Until, let's say, at the forward selection step, no more variables get added. And then at the backward elimination step, no more variables get dropped. So the model becomes stable. I mean, I will not talk too much about the selected groups, but based on experience and the kind of variables that we have, we created these seven groups, yes, of variables that, for example, for us, we know that we cannot really put together the industrialized economies with the developing or emerging economies because they follow really different trends. So that's why we create two groups separating the indicators there. We also have something on supply and demand, some on the PMIs, for example, etc. And this is a performance. Normally, this, in our experience, this converges very quickly. So here is the initial kind of this, just the key variables that we took. We took about 6 or 7, so just a very skeletal model to get started with. That was not a very good fit. But then by the first iteration, the average error goes down to a very low number, and then it kind of very quickly converges. So that between the 4th and the 5th iteration, there was no change in the variables included in the model, and we stopped. So it was the convergence criterion. And this is our final model. And for us, it has worked really well. It's relatively fast. It's also an automatic algorithm, which is important when in the future, when we have to do this kind of country level nowcast. So it's something that we can program, or we have programmed, and we can just implement at the country level and to arrive to the final model. So just as a conclusion, I think these kind of ad hoc solutions are criticized there because there's not really we cannot really evaluate if they're optimal, if they really reach the best model or not. But I think it makes it gives a good balance of something that it's performing well. So here we're testing a lot of models. We're still testing all the variables repeatedly. So we're sure that none of them just get neglected or forgotten there. And also it remains feasible. It's something that can be done relatively quickly in any normal computer. So I think it strikes a good balance. Of course, this bringing kind of this non-statistical information from the subject matter knowledge, it may not be well seen, but this is something very common, like in many of the other exercise on nowcasting, this list of exogenous indicators is also introduced at the beginning. So I think it's kind of part of something that needs to be done. And what it does is what makes the model, it gives structure to the model and makes the estimation feasible. Of course, as Dan was mentioned before, there's a lot of developments in this kind of high dimensional data spaces modeling in machine learning and in other shrinkage model that we also will have to or will want to explore. There's also this discussion of which one is better, sparse modeling versus dense modeling. Sparse modeling is something like I describe here, where only a few of the indicators are taken as relevant and the other ones, their coefficients are basically restricted to be equal to 0, versus a dense modeling where this is determined within by using the information provided by the data itself. I mean, this is something that we still need to explore and see if it's feasible in such a situation, but it's also worth exploring. So it's a very quick walkthrough of what we're doing. We will publish a working paper, hopefully in the fall. So there will be more information there, and there's my email as well in case you have any questions or you want to discuss this further. I will, as Dan, I will also, once this is ready, I will make the code available for anyone interested in reproducing this. So thank you so much. Thanks,
Fernando. So I don't see any questions in the chat. If another participant wants to ask one, if not, I had one or two questions. So one question was about the possibility of these sort of meta model predictions. So in the machine learning context, it's perfectly normal and common to take the output of many different models and a sort of meta prediction. And when I see the graph of your random sampling of variables, and you get this almost like a normal distribution centered around something, do you think that there's any maybe one day scope for research or interest in saying, what if we took that mean, that 1.5 of your distribution, as the prediction, even if no individual model said that, and you wouldn't necessarily have coefficients producing that output, but obviously there's some sort of information content there where these models are centered around a certain number, and that potentially could be useful to take as a prediction. Do you think there's any scope for that in this field that you're talking about, or that's a bit too lacking in hard, interpretability?
No, I think this model averaging it's a common process. It's used. I would say that there's studies and there's evidence of its performance and how it works in different situations. The problem here is it will still require to estimate many models, which can become problematic in this situation. So it's not that we don't want to explore. I mean, we're obviously happy to explore, but we really want to confine ourselves to things that we can easily implement and reproduce. Also remembering that we cannot just, invest 1 month of all of our computers and run all the models and that's it. But these models need to be recalibrated frequently. So it's a kind of an ongoing process that we also need to take into account. So of course, there's a lot of options to explore, but we're really trying to keep this kind of computational time low.
Makes a lot of sense. I had one last question, if no one else had one. Algorithm sounds very interesting and very relevant for any model selection, but especially nowcasting, where you have so many potential explanatory variables. I was just curious how the runtime of the algorithm scales with the number of variables. So say you had 10 potential variables and you double it to 20. Will this algorithm actually take the same amount of time, or will it take twice? Will it take squared? Like, how does it scale to the number of potential variables?
Yeah, I don't have that information right now. It's something that, as you say, it's something very important to track and keep an eye on it, and we will definitely do in the paper. But it is exponential. Like you show in your graph, if you double the number of variables, it will not take double time. Take more because there's all these variance and covariance that needs to be estimated as well. So yeah, it increases substantially. So
sense. Cool. So there's nothing else. It's again right on time to move ahead to Rosa's presentation. So Rosa, you have the floor.
Thank you, everybody. Can you somewhat tell me if you can see the screen, please?
Yes, we can. It's good.
Thank you. Then in this presentation, I would like to show you the Eurostat business cycle clock. I would like to do this quite rapidly because the main message of this presentation is what is happening in the last months, what happened to the input variable in the tool. Then I will talk shortly about the different economic cycles, the sequence of turning point, our business cycle clock tool, and then I will concentrate on the input variables and the current situation, the last signals from the tool. Why we decide to develop this tool? We are in charge of the scoreboard of principal European economic indicators. This is quite interesting, but we have different ones like GDP, inflation, and so on. And you cannot have a signal from this large scoreboards. And then we wanted to see what is happening to the cycle and the economy in general. And this is why we developed this tool. What is the business cycle clock? Is a visualization tool where we try to put all together turning points of 3 different cycles. Why? Because we want to represent the economic activity in terms of recession or expansion, slowdown, and accelerating or decelerating growth. This tool is interactive. If you want to play with it, please do it, and we will be happy to have your feedback. You will find it on Eurostat website. In particular, it is linked from the PI's webpage. If there is time, we could even make a tour of the tool. Which are the cycles that we monitoring in the tool? We have 3 cycles, the classical business one in the definition of Bartz and Mitchell. This cycle is characterized by a quite long expansion phase. Then if you just look to the business cycle, you don't have a lot going on. Then we also have the growth cycle, that is the deviation of the trend of outward gap. That is very important to know where is your potential output, and usually anticipate business cycle peaks. Then we have the growth rate cycle, that is the more volatile one, where you have more up and down and then more peaks and through. In our business cycle tool, we monitor those 3 cycles together. It's a joint monitoring of the 3 cycles. And this is done via a sequence of turning points. How do we do? We have, for each cycle, we have a coincidence indicator that takes the name of the cycle, the growth cycle coincidence indicator, business cycle coincidence indicator, and acceleration one. What does it mean? That you have probability, that is a number between 0 and 1. And for the growth cycle, you have the probability of being in a slowdown. For the business cycle, we have the probability of being in a recession. And the acceleration cycle will give you the probability that your growth is accelerating or decelerating. How we combine all those things together? First of all, I would like to show that there is a sequence in time of this point. This means that you start in a point alpha, that is when your acceleration is growing. Then you go in the point A, that is the peak of the classical cycle. Then you reach B, that is the peak of the growth rate cycle. And then you start to decelerate. You go through the flow of the acceleration cycle, through the flow of the growth, and through the flow of the business. And this is what we call alpha A, B, beta, C, D sequence. Now that we have a little bit of the context, how we wanted to have something that is clear for the user. We have all those points, those turning points, but we wanted to have a single image. And this is why we decided to have a clock that is divided in several zones, where the end of the clock indicate the current position of the economy. This image, you can also find it on the help online of the business cycle clock. And as I was telling before, we have this different turning point. When you are between A and D, you are in expansion phase, the color will be more green. When you are between D and A, you are in expansion. Between A and D, you are in a slowdown, recession, recovery. And here you have all the points with the different phase. And clearly, is more or less cyclical in the sense is not really a strict sequence. For example, the acceleration cycle has more up and down. Then sometimes you can move between B and C before going to D. Or sometimes A and B can be on the same moment or the same time. Then it's not strictly a sequence in the sense that each time you find the point, you find the other one, but it is a logical sequence. You will never go from B to alpha without going through all the other points. And here is the formula to compute a position of the end. You have 3 probabilities, that means a number between 0 and 1, and the combination of these 3 probabilities will give you the sector where the end will be located. Just for your information, I am not touching on the methodology behind. There are plenty of papers and bibliography if you want to know more. These are multivariate Markov switching model. We have 2 models, one that jointly estimates the business cycle clock indicators and the growth cycle constant indicator, and one that is for the acceleration cycle constant indicator. The coverage is the euro area and its member countries. We mainly focus on euro area. Now, let's now look at the variables that are the input of this clock and what is happening in the recent month. The first model is based on industrial production index. Fernando was already talking about it, but fortunately we are in euro area, then we don't have problem. The indicator is monthly produced and is produced and available for all countries. Then we have the unemployment rate, and then we have 2 variables that come from the business consumer surveys. This means that these are what is called soft data. They are surveys where you ask to a manager, for example, what he thinks about employment expectation for the months ahead. Then these are more opinion. And then you have the acceleration cycle constant indicator that is based on the economic sentiment indicator that is also coming from the business consumer surveys, and is a kind of synthetic measure of the different surveys that cover industry, consumer, and so on. Then we can now look at the current situation, what is happening in the input variables. We want to see if we are recovering or not, and I would like to share some consideration about the current situation. If you look at the industrial production, I will show a graph in the next slides, you see that things look well. And the values in April 21 are just where we were before the pandemic. Unemployment is quite stable, and the business and consumer surveys give quite optimistic signal. More in detail, what was the effect of the pandemic on the industrial production? First of all, some enterprise just closed, and clearly their first worry was not answering to survey or question, so that there was, for some enterprises, there was no data at all. The collection was more delayed, and as a consequence of this situation, there was more uncertainty and more revision of the data. Moreover, the industrial production is a typical variable that is characterized by strong seasonality. What does it mean? This means that it was difficult during the pandemic to estimate the seasonal pattern. You were in front of outliers. You have to decide what kind of outliers you have, and you cannot count on the past because this was a disruptive event. Then all thing that was kind of auto-regression was not working. The decision on the outlier would impact your path, and there were not clear insight of what was better. Now looking at the data, this is the current situation. Now you can see in this graph how the index evolved when you rebase considering February 2020 as 100, and you can clearly see that the point is at the same 8. Then we are back to the value in April 2021 to the value that we had before the pandemic. And this situation is, however, not uniform in all countries. In this graph, you can see with a triangle, you can see the lowest point across member states in the euro area, and with the diamond, you can see the highest value. Then the situation in the country is not the same everywhere, but the euro area as a whole is back to the pre-pandemic level. What is happening with the unemployment rate? Here, I will be a little bit more cautious because I can go forth and back from the graph. If you look at the graph, it seems that the situation is not so bad. We had the kind of flu, then it was a little bit up, then down, but not dramatic changes. Why? This is more my personal interpretation. First of all, the status of people changed. The number of hours worked decreased. There were people working less, and there were even people that were out of the labor force because by definition they were not able for searching actively for a job. Maybe they were under lockdown, they have children at home, they could not search for a job. Then this has impacted on the general results of this variable. However, now there is still some uncertainty linked to two things. From one side, there was a lot of state aid. There were national support schemes for the labor market. And this also was very good to keep unemployment rate low. But this, they could stop, it's not very clear. It depends from the country when and what the impact will be. And this could have a negative impact. And on the other way, we also have a lot of new support that come from the European funds, and this could have a positive impact. Then here I will say that we have to look what will be the combined effect of all these things that are happening and where we will go. The European sentiment indicator that, as I was saying to you, is more from the business and consumer survey. From another side, it looked very optimistic. We are even values that are even better of what was before pandemic. And this is not only for Euro area, but for a number of countries. And it looks quite optimistic together with with most of the business and consumer surveys. Other variables that are not in the tool but can contribute to the general situation, economic situation, is that we are still some uncertainty. Some data could be revised more in the future. There is some attention to inflation because now it's close to 2%. That was a critical value in the past, but seems to be more acceptable in the current situation. But if you look to excess mortality, we have an indicator, we defined the Eurostat in the period of the crisis of the pandemic, an excess mortality indicator where each month is compared to an average over the year 2016-2019 of the same month. And this indicator is still going up. Then I hope that in the following months, following the effect of the vaccination, this will show better data. But with the data that we have until April, this was not still in good shape, I would say. We are not back to normal for excess mortality. Looking at the GDP, we are also in the first quarter 2021 for the Euro area is still below quarter 4 2019 and by 5.1%. There too, there is still some, is quarter 1 2021, there were still containment measures, but there is still room for improvement for the economy. Okay, now I can be fast and show you some results from the clock. In 2019, December 2019, before the full pandemic, the situation was a little bit mixed. Some countries were in expansion, some were in the bottom part of the clock. It was not a very clear signal. What is happening now? This is the last information that we have, and you can easily see that it looks green. We have our result either in clock, as I showed you before, or in a map. And I find that the map is a nice way to look at the situation all at once. And you see that there is a lot of green that is good up for the moment. These are how the clock looks now. You can see at the same time up to 6 o'clock in the tool, and you can select the country that you like. And you can see that with the session of Netherlands, all of these ends are up. Then we are in an expansion phase. To conclude, leave some time for question. The signal of the business cycle clock look optimistic for the moment. Clearly, we have to wait to see if the situation is confirmed due to the uncertainty of the moment. But we are not the only one thinking that the economy is recovering even better of what it could be foreseen. Thank you for your attention.
Thank you so much, Rosa. Very interesting application, and thanks a lot for having the presentation. So there's no questions in the chat. If any participants have any questions, if not, I do have one. Okay, so I'll go ahead and ask my question. So the clock is a point estimate, it seems, so estimating the state of the economy right now. I'm just curious if there's any temporal aspect, like the any kind of prediction of where the economy will be in the coming months, or how much longer it will stay in its current state, or is it really just a point estimate and that's up to the analysts to decide?
Okay, in general, we don't do forecast. We can do nowcast, but we don't do forecast. On the contrary, what we do is looking at the past. And one of the things that I plan to do is look how the indicator were revised during COVID, if the signal changed, and so on. And there is a recent paper written by me, and I will take the occasion to thank the person that was reviewing it, that it should be connected, because thanks to his suggestion, I inserted in the paper how was performing with the last crisis. And then you see, and this will give you an idea of how it was doing in the past. And I would like to add some more revision analysis on what happened now, but we don't do forecasts. If you want, if there are no question, we could have a small view at the tool.
Yeah, that would be great. Fernando has one question, but you can get it set up.
You can do it, and I will answer in parallel if you wish.
Yeah. So Fernando, go ahead.
Yes, thank you. So my question is, so you mentioned this, the model behind this is
Markov switching model.
Markov switching model. So because in some of our, I mean, not even this, even if in some of our simpler models, just for seasonal adjustment, we saw that the shock during COVID was so big in some months that just the models were producing nonsensical results. So I was wondering if at least for some countries, you had a similar situation where the model was really off because of the magnitude of the shock, or it was still performing well?
You are completely right, because the problem was that, for example, the industrial production index have a volatility, I don't know how many times is standard deviation, and then we had to use some techniques to adapt the model. In particular, we trimmed some values, and then we adapted the model, and it was okay. But clearly, we have to intervene on the model, because in this moment everything was very, very shaky.
Thank you.
You're welcome. Then this is the tool, how it looks, and you have a lot of different possibilities. For example, you can go to the map, you can go back to the linear graph, you can select the last 15 years and see what is happening. You will have, here you see you have the growth cycle percentage of deviation from the trend. I didn't have the time to show all of this, but for example, these points refer to the euro area, to the slowdown recession phase of the euro area. As soon as you select another country, this will update it with a new country. You can select up to 6 countries. You can download the PDF with these images and so on. Then please play with it. And we plan a little restylishing of the tool. Then whatever comment you can give to us, this is the best moment, and we will take them in consideration. Many thanks.
Thanks so much, Rosa. So that's a great final note. So we have one last question. We have perfectly 5 minutes to go into it from Anu. I'm just going to read it out. It's for all 4 of the panelists. So she asks, do you think there's hope for improving the timeliness of SDG indicators with nowcasting before the end of the 2030 agenda? Should we select key SDG indicators to be nowcast based on their importance for policy or development, and or based on the indicator's suitability for nowcasting? What steps in general would you recommend? So anybody is free to take a stab.
So I can get started maybe.
Please, Fernando.
But very quickly. So I think, well, I don't think selecting indicators based on importance, but I mean, all of them are important in a way and in certain fields. So, but certainly there are some indicators that are more, how do you say, suitable for nowcasting. So that means those indicators where there's bigger lags until the information is published, and where there's a lot of information out there that we can use. I think I'm thinking of all the poverty indicators, maybe these kind of health or education related indicators as well, where there's a lot of external information, very timely, that we can start using. And we don't have to wait until it becomes available. But that's just my opinion.
Okay, may I also give my answer?
Please.
I think that it depends, because the SDGs is very, very large. What I can see around is that, for example, Eurostat has started to publish some nowcasting on income and wealth. Then what is macroeconomic, etc., is more maybe suited for those kind of approach. But there are other things where the new fuel will come from for example, sensor, big data, their air pollution, all those things. I don't know if we can nowcast it with the same method that we are doing. It's not time series, something different. And there are geospatial systems that are going very well for the moment. There is a lot in what is called trusted smart statistics. There should be a session in ISI also organized by Eurostat. Look around, there are a lot of nice things moving.
Yeah, so my take, I very much agree that it's the suitability to be nowcast should be the determining factor, because if you have an indicator that's just not suited, no matter how important it is on a policy level, if you can't nowcast it, you can't nowcast it. So really that should be the guiding principle, is how appropriate are these methods for nowcasting the variable, and how useful is it. As Rosa said, these things with the big data and sensors, that's more about using that data to almost populate new indicators or new ways of measuring the indicators, whereas the nowcasting is going to be more suitable for getting answers about the state of an existing indicator more quickly, not something, completely new or a new way of estimating something. So I think that's kind of the main principle. Do you want to say something, Julia, about it, or we have one hand up, so we have time for one last question, unless you have something to say, Julia? Okay, then why don't we have Elena go ahead and ask your question. Let's see if we can squeeze it in quickly.
I'm curious about when the nowcasting adds and the near-term forecasting starts in your area of research, because of, clearly the data coming with delays, but the aim is not only to talk about today, but maybe with a near-term future. So please define a little bit more clearly your definition of nowcasting, near-term forecasting, forecasting in general. Thank you.
So at least at UNCTAD, I can speak for, we start producing the nowcasts indeed before the quarter has actually started. So it is a forecast in that sense. A couple weeks or about a month before the quarter actually begins, we'll already start producing nowcasts or estimates. So the time scale depends on the application, of course, but for sure, nowcasting covers this range both before and after the period, not only during it. But of course, during is the most relevant, because you are getting real information about the period. But at least from UNCTAD's perspective, the nowcasting exercise does begin before the actual period, but not much before. So we wouldn't really nowcast 2 quarters ahead, but just the coming quarter. And that's from our experience, but the others may have different takes.
So from us is the same. So I guess nowcasting it's when you have already observed information for the quarter you're estimating, actual information, just not your target variable. But you can use this kind of information from other variables for the period of interest to produce an outcast. Forecasting will be really a period in the future where there's no information on any of the variables, and they're all extended. We try to feed a model to produce the forecast.
So with that, we're a little bit over time, 1 minute over. So I think that will do it for this session. As I said, I hope that these will be.
If I can, very shortly.
Yeah, please, Rosa.
There is the concept of nowcasting in official statistics, and there is no time to talk about it. Nowcasting is current period, but in the handbook of rapid estimate, there is a glossary, and there are a lot of definition aspects that you have to consider in official statistics, and they are quite well described.
Great, thanks, Rosa. So we'll upload everybody's presentation to the ISI portal. So please take a look there if you would like to look at some of the further information there, and reach out to any of the participants if you have further questions. So with that, thank you, and enjoy the next session.
Thank you, and thank you, everyone.